Okay, we're back. We had been figuring out the monthly payment formula, and now we're doing part 2. We did all these calculations trying to figure out the amount left to pay after month 2, month 3. And we finally figured out a formula by looking at the pattern for the amount left to pay after month n. And if n is the number of monthly payments here, then after n months we should get 0, right? So it should be that after month n we should get that would equal 0. So let's go ahead and try to work with this and try to kind of simplify it, manipulate it so that it ends up looking like this formula once we solve for this m. Okay, so m is in a whole bunch of places, right? But fortunately it's at minus m, minus m, minus m, and we can factor all of that out. So let's go ahead and do that. So here's a minus m, and we can factor it out of all of this right here. So 1 plus r over 12 to the n minus 1. And then notice it's going to be, since we factored out a minus 1, plus dot dot dot, plus 1 plus r over 12 plus 1 is equal to 0. Okay, so that looks a little bit better. And what's nice about factoring out that m is now that we have it factored out, maybe we can isolate it and solve for it. And that's what we're going to do next. Okay, so there's that formula. We want to set it equal to 0. So solving for this m, the first thing we can do is maybe take all of this minus m times this sum and put it to the other side of the equal sign. So we add this to both sides, and we end up with p times 1 plus r over 12 to the nth power is equal to positive m times this long thing. And then to solve for m, all we have to do now is to divide by the sum on both sides. So then this is going to be p times 1 plus r over 12 to the nth power divided by that whole thing. 1 plus r over 12 to the n minus 1 plus dot 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 plus 1 plus r over 12 plus 1, and that's going to equal m. Now this looks a little bit different from this right here, right? So where are we getting this other formula right here? It doesn't have this big long summation in it. And you know, say you have a 10-year loan, it's 120 months. You don't want to calculate all of this and add together 120 things. So there's a way that we can rewrite this in a much nicer way. And here's how you do it. Okay, so let's kind of rewrite this in terms of an x. Okay, so we're going to write x is equal to 1 plus r over 12. That's just so that we don't have to keep writing 1 plus r over 12, 1 plus r over 12 over and over again. Okay, so if we rewrite this sum, and let's call it s, s is equal to, now this is x now, so this is x to the n minus 1 plus, and dot dot dot, plus x plus 1. Okay, and so that's what x is. It's x to the n minus 1 plus x to the n minus 2 plus, keep going until you get down to x plus 1 at the very end. And we're going to do something, you know, maybe a little weird, but you'll see why it's helpful in just a second. We're going to multiply s by x. So when we multiply s by x, that's x times x to the n minus 1 plus dot 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 plus x plus 1. We're going to multiply x in here, and we multiply it to all of them, we end up with x to the n plus, now I'm going to write the next one up. So I would have written x to the n minus 1 plus x to the n minus 2, multiply that by x, and we're going to get x to the n minus 1, right? Plus all the way down to x squared, and then plus x. Okay, so then what we're going to do from here is something a little bit different from what we did in class. We're going to take x times s minus s instead of s minus x times s. And it's just going to make the calculations a little bit easier. So it's x times s minus s. Okay, so when we do that, we take this right here, and you subtract off this right here. And so we start off with x to the n, and then we're going to have an x to the n minus 1 minus x to the n minus 1. So that cancels out. And before this one, there would have been like an x squared. Well, this x squared and this one will cancel out because it's x squared minus that one, and it's x minus that x. So all we're left with is, since we're subtracting off s, a minus 1. And that's all that's left over when you do x to the s minus s. And that's why we do that. When we subtract it off, then it really simplifies things. So notice s is in both places, so we can factor it out. Like that. And now we can solve for s. And so by dividing by x minus 1, we get x to the n minus 1 over x minus 1. And that is a really simple form for this complicated summation up here. And now we can re-substitute what the x was, and we can write down, let's see, 1 plus r over 12 to the n minus 1 over 1 plus r over 12 minus 1, now that we have substituted in what x actually equals. Okay, and so this is what we are going to substitute in up here, because they equal the same thing. Okay, so in doing that, I'm going to write it on the other side of this m. So when we substitute this one in here, we are going to get p times 1 plus r over 12 times n, and we're going to divide that by this, 1 plus r over 12 to the n minus 1 divided by, now notice what's going on here. I'm just going to simplify this a little bit down here. 1 plus r over 12 minus 1. We can take out the 1 and the minus 1, and we're just left with this r over 12. So that's what I'm going to write on the bottom here. It's just r over 12. Okay, we don't want to leave it in this complicated fraction form, so notice what we can do is multiply top and bottom by r over 12. In a sense, we're just multiplying by 1. Right, so r over 12 divided by r over 12 is just 1, so multiplying by 1 doesn't change anything. But what that helps us to do is to get that r over 12 out of the denominator. And now to get it to look like the form over here, let's see if we can do this, that we want. Well, we got that part. And now we just multiply this in here, and I just reordered things so that we write p times r over 12 times 1 plus r over 12 to the nth power over 1 plus r over 12 to the nth power minus 1. So once I simplify this, I get this formula. Yay, the end.